Hello, today I will be presenting my senior project, and what I'm doing is SOA testing, which is safe operating area testing of gallium nitride on silicon enhancement mode MOSFETs, or enhancement mode FETs, field effect transistors. Um, so I'm doing this uh, project for the company Navitas Semiconductor, and they are a company that develops semiconductor chips using gallium nitride on silicon, as opposed to your standard silicon or silicon carbide. And they were looking for someone to develop and run safe operating area tests on their devices, and they will be the first customer of the safe operating area tests that I will be developing and running. So what a safe operating area test is, it is used to define the parameters under which the device under testing is safe to operate without self-damaging. And the two safe operating area tests are reverse biased and forward biased of the device under test, or DUT. So for this project, my testing requirements are that the tests will be reproducible, and it will also produce a family of curves. The test shall be presented in a readable and editable format. The temperature within the FET shall be measured as close to the die as possible, and the minimum amount of components must be used on the PCB for the test boards. So to go over this, the reproducible testing is to ensure a low cost, and to ensure that the testing is reproducible, I will define that as the only component needing to be replaced on the test boards is the FET that is being tested. And the reason that this is important is because um, it lowers the cost and allows tests to be run quicker, and which saves the company money as well. And the way that I'm going to be ensuring this is by adding a protective circuitry to the test boards in case of failure of the DUT. And next, the test is going to have to produce a family of curves. This is going to be done by running the test at different input pulses. And you'll see in the next slide a picture of what this is going to look like. For this project, the test will be run at 100 nanoseconds, 500 nanoseconds, 1 microsecond, and 5 microsecond, and these were determined by the switching speed of the device and by the data sheet that the device that Navitas has provided me. And anything below the curve in the family of curves is considered to be part of the safe operating area. And here is an example of a safe operating area curve. Here you can see as the time increases, the area under which the time of the pulse increases, the area under which the device is safe to run at is decreasing. And next is the temperature measurement. The temperature measurement will be measured as close to the eye as possible, and this will be done by using a thermocouple as close to the package on the test board. And the reason I can do this is because I'm assuming that the temperature at the die will be assumed to be the same all the way throughout the package of the DUT. And the reason that this is a safe assumption is because the die size and the package size is very small, so the thermal equilibrium should not be the thermal equilibrium. There should be thermal equilibrium all throughout the DUT. And another requirement is that I'm going to be using the minimum amount of components, and the purpose of this is to keep the price of the project to a minimum. And by minimizing the amount of components that need to be replaced, it will be easier to repeat and will be more cost effective. Now I'll be talking about my business model canvas. Here is an example of what a business model canvas looks like. We've all filled one out. So I'm going to be going over each section of that, starting with the key partners. The key partners of my project will be Navitas Semiconductor, which is they will be providing the DUTs and will be crucial in defining the market requirements and the customer needs of this project, as they are my first customer. And another key partner is Cal Poly, because the university is going to be providing me the equipment necessary for testing and the knowledge and resources required to complete the project. And the third key partner is Bay Area Circuits, which it doesn't have to be Bay Area Circuits, but this is just an example of a PCB fab company, and they're going to be necessary for fabricating the test boards that I'll be using to run my safe operating area tests. Next is the key activities. This is the next section of the business model canvas. And the key activities are going to include maintaining good customer relationships and running reliable tests and valuing the need of the customers. The key resources are getting money from the company or the school for PC fabrication, as well as the tools and measurement devices at Cal Poly. The value propositions is the next section of the testing, or of the business model canvas, excuse me. And the value propositions are that I will be developing a safe operating area test for discrete GaN on silicon E-mode FETs at a low cost, and it will be reusable for all discrete GaN on silicon FETs. And there's a market need filled by this product for small companies that don't have the resources or the manpower to develop tests on their own, or don't have the time to do it because they have other more important time-sensitive projects, such as tape out of their new devices. And there's currently no competing companies that do SOA testing for GaN on silicon FETs for third-party companies. Next is the customer relationships. And for my project with Navitas, or for my relationship with Navitas, I will be doing quarterly progress reports, as well as having an open dialogue between Navitas and myself with questions and or concerns about the project. The next portion is the channels, and that the channel for this product is I'll be working directly with the company, which is my client, Navitas Semiconductor. The next portion of the business model canvas is customer segments, and the customers for this product are companies that are developing GaN on silicon FETs and are in the testing and development stage of their process of creating GaN on silicon FETs. And the customer that has already been established is Navitas, so the products and results will be put into industry immediately when they're completed. And there's also a potential to sell test boards to other companies, such as Texas Instruments, or EPC, which is Energy Proficiency Company. And the cost structure is the next portion of the business model canvas. And the cost structure is to be determined by the amount of components and PCB boards that are going to be necessary for testing. And the main goal, obviously, of a company is to be making more money than is being spent. The last portion is revenue streams, and the revenue streams will be set by the level of customer service that is being provided. And as said multiple times, Navitas Semi is the first customer. And if you have any questions, you can ask me in class when I present this again. Thank you for your time. And also, I'm going to email you these slides because I was not able to present them and show them at the same time.